Higgs boson,
चंद्रशेखर लिमिट,
string theory,
न्यूट्रिनोस,
quantum entanglement.
कुछ समझा क्या?
Ever felt bored and confused while reading lengthy physics textbooks or articles?
Yeah, on God, bro.
I'm Arnav,
And I'm Pratham.
and welcome to Quark Talk, where we decode all the complexities and simplify these intricate concepts in physics.
They may have seemed too complex to understand until now. You know, Arnav, I read an article, How to Break the Universe in 3 Easy Steps.
Ah, yes, another Tuesday. Let me guess. Someone cracked faster than light travel.
Exactly. This guy thinks that if you just spin a giant carbon nanotube tether fast enough, the tip will hit light speed and bam, we're out of the solar system by dinner.
Beautiful, except, of course, the minor detail that physics doesn't work like that, right?
Minor detail, yes. Like how infinity is not a number you can casually summon with an engine and a prayer.
Let's just take a step back, right? Why can't anything go faster than light? Why is light the cosmic speed limit? And, like what happened to your article? Like, everything. Let's just take a step back.
Okay. It all goes back to Einstein's special theory of relativity. Basically, the universe has a speed limit, and that speed limit is 299792458 meters per second. You go faster than that, and reality starts handing you error messages.
Right. Space and time themselves say, "Oh, there, cowboy." But here's where it gets fun. People still try to cheat the system, like the laser on the moon trick.
Ah, the classic.
Yeah.
You shine a laser at the moon, you flick your wrist just a little bit, and voila. The laser spot moves across the lunar surface faster than light.
But here's the catch. Nothing actually moved across the moon at that speed. The photons are still traveling at regular light speed. All you're doing is changing where those photons land. So the spot moves fast, but no information or object does.
Yeah, it's like blaming your shadow for teleporting. It's just geometry, not teleportation.
Yeah, it's like the moon on the thing is just like you can say it's an illusion per se. Like.
Yeah.
So fine, no faster than light communication or FTL communication, no time travel yet. Just a fancy flashlight party trick, right? That's a moon one.
Okay, but what about a more tangible solution? Let's say we ditch the lasers. Let's go full caveman, a giant stick. You push the base, the tip moves faster than light, right?
So you're saying let's be more specific. Basically, we have a giant stick that goes, like you're holding it, or you have some mechanism that holds it, and it extends to the moon.
Extends to the surface of the moon.
Yeah.
You just flick your wrist.
Yeah.
Basically the same thing with
the light,
laser.
but without the laser.
Yeah.
So you move the stick, and so you're hypothetically the tip moves faster than light, right?
Yeah.
In theory, I mean, sure, but in reality, congratulations, you've rediscovered the speed of sound in a solid.
Yeah, every atom in that stick has to nudge the next one. The force travels at the speed of sound, not even light. So
it's really short, really slow then.
Yeah. So even if it is a really stiff space stick made of imaginary whatever strongest metal you want to call it, you're still capped by physics.
Yeah, also loss of energy. Like by the time you're a little push, like even if you're benching 500 kilos with one hand, but even your little push reaches the tip of your moonstick, you've got basically nothing. It's like shouting down a mile-long tunnel and expecting a whisper to shatter windows.
Okay, fine. No lasers, no sticks. The third thing,
and final option.
Yeah, this article talked about.
Last resort.
Yeah, the big guns. Bro and his space age engine.
Yeah, yes. Star Trek and all. He hypothetically wants a motor spinning at 10,000 RPM. Deploying two slowly deploying two tethers. Made of carbon nanotubes. Each 285 kilometers long. And the tip is supposed to go at light speed.
Sounds like a pitch from a Marvel villain who skipped physics class.
Nice one. So here's the thing. Basically, there's something going up in space. It's a motor spinning at 10,000 RPM. It is slowly going to extend out 285 long tethers made of very strong carbon nanotubes. Like they're really, really strong.
Yes.
Like how like graphite and graphene and all like that.
Yeah. So you run the calculation and basically the tip goes faster than the speed of light. But of course, that's not true. Even in physics theory, not even the real world. So basically, when something moves in a circle, it needs centripetal force. the faster it spins, the more force it needs.
Because otherwise it has a tendency to escape the circle. Like, it just fly away.
It goes tangentially to
it. Yeah, exactly.
And this force basically scales with the square of the velocity.
So basically that means, in a nutshell, like Kosgazar in a nutshell, goat channel, it basically means that at 99% the speed of light, even let's say 1 gram of any mass needs 300 meganewtons. Okay, meganewtons of force. That's the weight of 6,000 African elephants, fully grown.
Okay, but
1 gram.
Yeah,
equivalent to 6,000 fully grown African elephants.
Yeah. That's all that is fine. What this guy suggested is that he thought carbon nanotubes are strong, right? They're very strong.
Yeah.
If you have
not strong enough.
If you just have a fiber 8 centimeter thick, you could technically hold that much force.
Yeah. So basically, it's really, really strong. But then what? That 1 gram tip is attached to fiber. The fiber itself has mass. So you need more strength to hold the fiber, which means thicker fiber, which means more mass, which means
yeah.
So
it's
endless cycle, except it does end at a certain point, but like it spirals. Like by the time you're 30 meters from the tip, okay, like from the tip of the end of the carbon nanotube wire, like the tube, like the tether, the fiber has to be thicker than the observable universe to handle the load. Like it doesn't end actually. Now it's like infinite basically, I guess. It basically spirals out of control.
The observable universe is not infinite.
No, it's not. It's like 95 light years, right?
Something, yeah.
95 million or something.
Yeah, something like that. It's
95 billion light years.
It's a finite number.
Yeah, it's 95 billion light years, but that's like still a lot. Yeah.
Yeah, slight over engineering, I'd say.
Yeah.
And even if you built it somehow, some way,
like everything's done till now.
Yeah.
Like you have 285 kilometer long, very strong and very thick carbon
nanotubes that are as wide as
at least as wide as because that's just 30 meters from the tip.
Yeah.
You have to go 285 kilometers from the tip as well.
That's true.
So that's
true.
That goes to.
So you start at like 8 centimeters and then you slowly make your way up to
95 billion light years, I think, is the number.
How much ever that is.
And then that goes even higher.
So yeah, even if you do that.
Yeah, everything's done. And you're spinning that entire thing at 10,000 RPM. And
you run into another wall, which is called relativistic mass.
And as you approach light speed, basically, inertia increases, like inertia.
Yeah.
Where do I need to explain it? I mean...
We need to. Okay, so basically...
like an object that's moving continues to move unless external forces are applied.
In a nutshell, basically, at very, very high speeds, close to the speed of light, 1 gram starts behaving like 7 grams, basically. That's the gamma...
Like the mass of any object that's going faster increases, basically.
Yeah.
Like relativistic
That's
mass.
the gamma factor for like traveling at such high speeds, basically.
So that 1 gram starts acting like 7, more and more and more. And as you get closer to light speed, the energy needed to accelerate keeps increasing without limit. So like E is equal to mc square, the energy required increases, C is constant because the mass increases. So as the relativistic mass, like the experienced mass, not the actual mass, but the experienced mass increases. So the energy required to move that experienced mass increases, and thus infinite energy is required.
Technically, if you move at the speed of light, you need infinite mass, which is not possible.
No, you don't need infinite mass.
Gamma becomes infinite.
You don't need you need infinite energy to move an infinite mass.
And it's the same thing.
But you don't need infinite
mass.
Gamma
shoots up to infinity.
So basically the point what we're trying to say is this thing. That if you want to move anything at the speed of light, it needs to have zero mass. That's it.
Yeah.
Like photons, which is light itself. So
correct.
So to actually hit the speed of light, you either need infinite energy, and even Elon Musk doesn't have any budget for light for that.
But wait, there's more. Let's pretend we beat all of that, okay?
New
materials, infinite energy, Bro's cosmic engine of doom.
10,000 RPM, everything.
One final boss.
Electromagnetism.
The stuff holding all matter together. All those
interparticular forces, basically.
All those forces, atoms attracting, repelling, bonding, they're carried by photons. Those very same photons obey that speed limit of light. we've been trying to break now for like a lot of time.
Yeah, so even your tether, no matter how awesome it is, or no matter how fast you're going or whatever, it can't hold itself together if the forces holding it are limited by the speed of light, right? So in the end, no information, no mass, no material, no signal, nothing can outrun light. It's the one law of the universe that hasn't flinched yet.
So what's the takeaway here? If you want to go faster than light, don't build a space tether. Build a science fiction novel.
Or you can, there are theories about how space itself can go faster than light, but that's for another episode.
Yeah, I remember reading in some article that, if you can bend space-time in such a way...
Yeah, you ride space-time as if it's like a wave kind of thing, right?
Yeah. If you can do that, then even general relativity technically permits you to go faster than the speed of light. But can you really bend space-time?
Yeah, that's the question that we will answer in the next episode, except we won't because no one knows. So we break the rules on paper, not in space. And if you try to do it in real life, wear a helmet that's preferably thicker than the observable universe, right? Because you need to be safe.
Yeah, so we've ruled out lasers, sticks, and tether-flinging cosmic Beyblades. But here's a twist. What if we're thinking about the problem the wrong way? What if instead of moving faster than light, like Arnav said, we can just move space itself?
Ah, yes, you're right. Classic cheat code. The Alcubierre warp drive, okay?
We're sorry again.
So it's like, sounds kind of cool though. Sounds really cool.
Yeah.
Okay? Alcubierre warp drive. Basically, it stretches space behind you, compresses it in front of you, and then, as I said earlier, you ride the wave like a cosmic surfer. Who needs speed when you can just drag space-time?
It's the physics equivalent of walking on a moving walkway and pretending you're sprinting. But here's the catch. It requires something called negative energy.
And I guess like negative mass and all, right?
Which is exactly a mood.
It's not a vibe.
Yeah.
Let's be vibing.
It's a literal type of energy that doesn't behave like anything we know.
Right. It's like an exotic type of matter that repels instead of attracts. Problem is, no one's ever seen it. It's just theoretical, and the theoretical amount that's needed to move that,
even a grain of sand.
Alcubierre warp drive, like the theoretical amount needed for that also is like a lot. And let's assume we need to move even a grain of sand, as you said, right?
Yeah.
The theoretical amount needed to move that is also astronomical. So you'd need like more negative energy that exists in the visible universe, assuming it exists. But yeah.
So it's a bit like saying, sure, I can buy that Lamborghini if I just win infinity lotteries in a row. Infinite.
Literally, that's perfect. Like, perfectly sums it up in a nutshell, right? So even if you somehow got your warp bubble going, Alcubierre space drive, you wouldn't be able to send a signal to control it from inside because, again, speed of light limit. So basically, you're stuck in your own space canoe, moving blindfolded through hyperspace.
Okay, so warp drives are still theoretical. But what about teleportation, like quantum entanglement? One particle feels what happens to its partner instantly, even across galaxies.
Yeah, that's a favorite, right? Quantum superposition and everything. We've spoken about it a bit earlier.
Yeah.
Right? So, but let's be clear. Entanglement is not faster than light communication. You can't use it to send a message or cheat on your data roaming plan across galaxies. Basically, when two particles are entangled, measuring one instantly determines the other one's state. So, like, if two particles have opposite spins, if you measure the spin of one particle, you know that the spin of the other particle is opposite. Like, simple as that. But, you know that that's what the case is right now. Like, that's there. But until you compare notes via regular speed communication, you don't know what the result was, right? No information travels faster than light.
Yeah, for now, we've just compared particles that are like on opposite ends of the earth. But we really need to do it. It's in theory, it's possible, but to even...
In theory, it's possible to like ends of the observable universe.
Yeah, but
in theory. Everything's theory.
It still takes a lot of time, basically.
Yeah, it's like playing quantum WhatsApp where your messages are encrypted and you need to meet the person in real life to decrypt them. Cool trick, but not a space highway where you can like send information, right?
Okay, hear me out now. What if light speed isn't the limit for everything? What if there's another, maybe, let's go science fiction here, layer of reality?
You're saying we live in a matrix or kind of thing.
Yeah.
glitch in the matrix.
Yeah, we're all a part of the matrix. We have a hidden sector where speeds just go brrr.
The hidden dimensional play where everything, like some physicists have toyed with this idea, right? Extra dimensions curled up in microscopic scales.
String theory and all that.
Interstellar, right? Interstellar with the multiple dimensions.
Yeah.
Or brains, like membranes in string theory.
Yeah.
We'll do an episode on that as well. Basically, floating in higher dimensional space, basically. And here's the thing, even in those models where I think someone has said we have like some 27 dimensions or something like that, some models like that, even in those models, our observable physics still seems stuck at light speed. So that's the sad part.
Yeah, so even if some hidden alien physics is playing 5D chess, our pieces are still glued to the board.
Yeah, only at the speed of light, very slow, right? Just tantalizingly slow. So even if tachyons, which are hypothetical particles that always go faster than light, so even if they existed, like everything's theoretical, bro, in physics. Now, what do you feel? But even if tachyons existed, which always go faster than light, as I said, they'll violate causality. As in, hi, I got your message before you sent it.
Time travel.
Yeah.
Imagine
that's what tachyons are supposedly going to be the key to.
Yeah, imagine breaking
even though
up with...
we don't even know they exist. Yeah, go ahead.
Imagine breaking up with someone and the breakup reaches them before the relationship even starts. Not great. Not great.
Yeah, PR square. Space-time says, and to that, whatever you said, space-time says to that, absolutely not. No, bro.
You know what bugs me though? Sci-fi is full of this stuff. Star Trek has a warp. Star Wars has hyperspace. The Flash just vibrates really hard and somehow time travels. Are we just ignoring physics and fiction?
Yes. And that's okay because sci-fi is a playground. It's for curiosity to blossom. It's for everything to feel free and roam free. So it's not a lecture hall like in Caltech where you like study a lot. It's basically you want to watch spaceships go zoom zoom and things go blast and boom boom. So like it's cool like that. So don't write your PhD proposal based on it because it's all fiction.
Yeah, but one thing I've noticed is that there's real value in this sci-fi, right?
Yeah.
Even if it's wrong, it gets people thinking. Half of the tech we use today was inspired by fiction. Communicators, tablets, AI also.
And our other half is like non-fiction, so keep that also in mind. Like how NASA builds everything in advance and then we get like, it goes to consumers like a couple of decades later, I guess. Like slowly but steadily. But whatever, fine. The warp stuff is like the dream fuel kind of thing. Like it's a dream team like of transport.
Yeah.
But there's a difference between inspired by and believes in, right? I love lightsabers. Doesn't mean I'm trying to weld one from microwave parts and regret like how Iron Man built his Iron Man suit from scrap parts.
Yeah.
Doesn't mean I'm trying to build my own lightsaber, right? Because I'm inspired by it. I don't believe in their existence. Kind of like
that. So basically to recap, faster than light travel is still fiction. Tether tricks, nope. Entanglement is misunderstood.
Ooh.
And warp drives need a physics miracle and $1 trillion exotic energy budget.
More like a gazillion dollar, bro. It's like
whatever.
Yeah. So exactly, the universe is still stingy with its cheat codes. It doesn't give. It's like very, 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 very strict.
But that doesn't mean it's boring. In fact, the limitations are what make it interesting. The challenge of working within the laws, bending them but not breaking them, is when real creativity lives.
Bendy machines.
Compliant
mechanisms. Yeah. No, but rules are meant to be broken apparently, right?
Yeah.
And that's literally why humanity is still pushing the frontier with telescopes peering into the early universe, with LIGO detecting ripples in space-time, apparently, and with particle accelerators smashing reality like it owes them money.
You know what we should be really focusing on?
Money? What?
No, fixing the Wi-Fi in my bedroom. It still travels slower than light. Feels like it uses carrier pigeons.
Messenger pigeons. You probably have quantum buffering or your Wi-Fi is... No, but it sounds cool.
It does. Okay. One last thing.
Anything quantum sounds cool, to be honest. Anything quantum.
Yeah. One last thing before we wrap. Let's just...
Warp? Before we warp or before we wrap?
Let's just say we do figure it out someday.
Assuming we do figure it out, yeah.
Maybe not by breaking the laws of physics, but by rewriting them. Maybe a paradigm shift, like when we went from Newton to Einstein.
Yeah, our physics play.
Yeah, sure. But we still have to remember Einstein didn't say Newton was wrong. He said Newton's laws are a special case of the bigger picture. It's not about tossing all out the rules. It's about zooming out.
And what we are saying is maybe FTL is out there, and if it is, it's not just faster travel, it's basically a deeper understanding of reality itself, which is what we say for every major thing on our episodes.
Yeah.
But yeah.
Until then, we're stuck obeying the speed limit. But hey, the view's still amazing at 299,792,458 meters per second.
Unless you're stuck behind someone in traffic going 299,792,457 meters per second. Then it's a nightmare.
1 meter, per second slower.
Behind. Yeah. Still faster than your Wi-Fi.
Hey.
Find out that Einstein thinks a special case in something else, like that. Special theory of relativity and general theory of relativity, like that. So maybe FTL is out there, but if it is, then it's not just faster travel, it's a deeper understanding of reality itself.
Yeah, until then we're just stuck obeying the speed limit. But hey, the view's still amazing at 299,792,458 meters per second.
Unless you're stuck behind someone in traffic going 299,792,457.
Then it's a nightmare.
Yeah, it's a kilometer per second slower. Still faster than your Wi-Fi though.
Yeah.